Hello everybody. So today we will be dealing with the concept of forecasting, which is one of the very basic component as far as production and operations management is concerned. And basically, since we are dealing with engineering economy, so forecasting for demand is becomes all the more important because we have to arrange the manufacturing facilities in such a way so as to meet the anticipated demand, because once the demand is met, only then we will be having the financial transactions. So if we just go by the definition of forecasting, it simply says that it is a tool which is used for predicting future demand based on the past demand information. Demand is particularly important in the present context. However, it may be used to predict any other phenomena as well. Like for example, in these days, we are basically going through an era of pandemic. So the same technique can be used to predict the number of infected persons in near future, maybe on the basis of days or months or years, whatever time domain we wish to select. Simply we can say that the demand is nothing but it is an estimate, forecasting is nothing but it is an estimate of the future demand. Now this can be more explained with the help of this diagram. What do we have? We have, say for example, if we have the actual sales for any item, so in this case, say for example, the sales or the demand for Mercedes in the past, we have the past data like January we have, February we have. So based on this data, what we are trying to do, we are trying to predict what will be the demand or what will be the forecast for the month of July. So the thing is, what we are basically trying to do, we are basically trying to predict the future by looking back at the past. Okay, so in this case, we have the data pertaining to 6 months. It may be pertaining to some years, past years. So the thing is that whenever we are giving some future estimates based on the previous data, that will be termed as demand forecasting. So a forecast can be determined. How it can be determined? It can be determined by mathematical means. Be historical. It can created subjectively by using estimates. Like for example, depending upon the condition of the weather today, we can predict what will be the condition of weather tomorrow. Okay, so there are some techniques which can give us some models for forecast depending upon some mathematical models, and we may have some models which are not mathematical, rather than it is based on one's subjective analysis. So that we'll see in the coming slides. So why the forecast is important? The very first thing is that once we have a forecast estimate with us, then it will reduce the uncertainty, because until and unless we don't have a forecast, we cannot plan for operations. Like if, say for example, if we wish to arrange the manufacturing facilities for near future, so we must know what should be the anticipated demand for which we have to arrange these machines. So that is why it, first of all, the very basic thing, that it reduces uncertainty, and the calculations which we are making with the help of this, they are having some basis rather than wild guesses. So to anticipate inventory and capacity demands, so basically it helps us to manage our inventories. Like for example, we can see that if the certain consumption of a certain item is high over a period of time, then more inventory of this particular item needs to be maintained. So that is why it helps us in proper inventory management. It helps us in assessing the project cost of operations, because once we have an anticipated forecast of anything, we can work out on the cost, because the cost we have to give in advance. So until and unless we don't have the data available with us, we can't go with the cost. So once a forecasted data is available, we can predict, or we can make calculations regarding the cost aspect. Of course, to improve competitiveness among the different firms and to improve the productivity by decreasing the cost. So once we have this data, we can plan all the components so that in this way we can enhance our productivity and unnecessary cost can be excluded from this, to improve delivery, and the last thing is to be responsive to customer needs. So these are the few points which basically tells us why the forecast is important for us. Now, as far as the methods of forecast are concerned, broadly speaking, we can divide the methods into two categories. One is qualitative and another one is quantitative. In qualitative methods, they are simply based on experience, one's judgment, one's knowledge, and these are basically subjective estimates. However, quantitative methods, they are based on some models, some data, some statistics. So that is the basic difference between the qualitative methods and the quantitative methods. Now, in qualitative methods, like the most important methods which are used as far as the qualitative analysis is concerned, like for example, the Delphi technique. So in this, what we do, we basically rely on the expert opinion in making predictions for future. We do have experts who tells us the forecast for any particular product for near future based on their experience. There are some methods which we call as extrapolative or time series methods. Basically, under these methods, what we do, we use the past history of demand to predict the future for any product. Similarly, we have some methods what we call as causal or explanatory methods. They are basically based on the assumption that demand for an item depends upon one or more independent factor. Regression analysis, we are trying to find out the relationship between demand and other factors, and once we establish a relationship between demand and other factors, we can have a form of equation, and then we put those variables into that equation to find out what will be the demand. So that is what we mean by causal or explanatory methods. Qualitative or judgmental methods, I have already told you, they basically rely on expert opinion in making prediction. We do have experts which are the expert of their particular area, and on the basis of on the knowledge base of those persons, we can have the value of the forecast for future. In some cases, we don't go for a single method. We can combine 2 or 3 methods just to have a better accuracy of the forecast. Now, if we just see the comparison between the two methods, like in case of qualitative, what do we have? We have market research. What we do in market research, we try to find out the customer habits. Whether if we are making a certain particular product, we first of all get the information pertaining to the taste of the customer, what the customer wants. So the thing is, this is especially true when we are making any new product. So if the customer wants certain features and those features are there in the product, then definitely that will fetch a higher demand from the market. So simply by making a market research, we can tell us what will be the future demand for any product. This is especially true when we are introducing some new product in the market. Then we have panel consensus. So the thing is, deriving future estimates from a synergy of panel experts in the area. Some experts in the area, they sit together, they debate upon, they discuss upon, and they come up with a conclusion based on their experience that what will be the future demand for any product. So that in that way we can have some future estimates. Then historical analogy, identifying another similar market. Let's say, for example, if we are entering into a market of a product which is already existing in the market, so the sales of that old product which is already there in the market, we can have some judgment or some forecast on the basis of the sales of the future item which is already existing in the market. Say for example, AC. If we are trying to introduce a new AC in the market, then the demand for an AC can be made analogous to the demand of the various brands which are already existing in the market. So, and this is another qualitative technique. And in Delphi technique, it is very much similar to the panel consensus. The only difference is that every person doesn't know the identity of another. So the thing is, all these persons, they are sitting in a separate room, they are basically making some calculations, they are on the basis of their experience, and then they are basically all the questionnaire, they are summed up together and they are given again a questionnaire until unless a common consensus arrives. So that is what we call as a Delphi technique. So these are some of the techniques which we generally use whenever we are dealing with qualitative method. Now under quantitative method, the most commonly used method is the time series analysis. So what do we have in a time series analysis? We have time on one axis and the demand on the another axis. So based on the past data and using the time series model, we can depict what the future trend will be. So that is time series analysis. Causal relationship, this is nothing but this is regression analysis. We try to find out the relationship between demand and rest of the variables and try to develop a mathematical formulation between the two. So once we know the relationship, it's quite easy for us to calculate the future demand or future forecast. Similarly, we can take the help of simulation software. So the advantage of simulation is that it takes into account the randomness and the non-linear effects also. However, these two effects, they are quite complex to model if in time series analysis and in causal relationships. So that is why this is another way by which we can give predictions regarding the future forecast. So this is the comparison between the qualitative and the quantitative methods. Now coming on to the quantitative methods, the first one is basically a time series method. So I have already told you, in time series method, what do we have? We have time on one axis and the demand or the forecast on another axis. So it is basically based on the idea that data relating to past demand can be used to predict future demand. So what happens in the past? In the past, we have two kind of data. One is what we have predicted or what we have forecasted and what are the actual sales. So we try to find out new forecast with the help of this data set. So that is basically what we do in the time series analysis. Basically, any time series method or any time series data, it basically composed of 5 things. Say for example, one is the base. Simply we can see if we have fluctuations in the data. So if we take up the mean, that is nothing but that is basically the base. Then apart from base, so say for example, if we have a data like this and the data is fluctuating like this, so base is nothing but if we take the average values and plot it, then this will be the base. Now apart from base, we may have a trend. Trend means if we just follow the data and we see whether the trend is in increasing direction or decreasing direction, means the hidden fact whether the data is continuously increasing or decreasing, that is basically known as a trend, which is depicted by this figure. Similarly, we have seasonality, like for example, winter season or summer season. If we take these things into account, so in winters, sales of blowers, room heaters and all those gadgets which are used for raising the temperature, that is high, and that is basically seasonal in nature. Similarly, we do have cyclic variations. So seasonality is somewhat similar to cyclic variations, but in some cases seasonality is not repeating over a period of time. Rather, cyclic variations, they are repeating over a fixed period of time. Seasonality means, say for example, there are certain countries where the temperature fluctuates too much. So you may require heater today, you may not require a heater tomorrow, but day after tomorrow again you require. So that is basically seasonal variation, but they are not cyclic in nature. And in cyclic variations, they basically repeat over a period of time. So any deviation from the base can be best explained if we take all these things into account, that is the trend, the cyclic variation or the seasonality. And even if there is some reason by which we cannot explain the difference between the actual value and the predicted value, we call this as due to the randomness in data. So randomness means whatever residue we are unable to explain between the actual value and the predicted value, that is because of randomness. So these are the few properties which any time series data is having. Now based on this time series data, we have certain methods by which we can predict or we can give the forecast. So some of these methods we will be discussing, like coming on to moving averages. So what we do in moving averages, we try to predict the future based on the past data, but In moving average method, say for example, if we may have a large amount of past data, but which data is more important for us? A 10-year-old data or just a 5-year-old data? Obviously, the 5-year-old data is much more important as compared to 10-year-old data. So what we do in moving averages, we try to drop the past data and we try to incorporate the new data in order to predict the future. So that is why this is known as moving averages. Say for example, this is basically the relationship, so it can be best explained with the help of this example. Say for example, if I take, so this is the time period given in weeks, and if I am interested in calculating the 4-month moving average, so what do we have? Say for example, we have, if we just take these 4 months, that is 73, 106, 76 and 86, and if we take the mean of these 4 values, it comes out to be 86. Fine. Now for the next time period, again, if we are using the same 4-month moving average, what we do, we drop the past data and we take into account the new data. So in that case, this 73 will be dropped and the next 4 months will be taken into account, that is 106, 76, 89 and 106. So that will be the new forecast for the 5th month. Similarly, for the next month, we drop these 2 values and we take into account a new value. So in this way, we keep on calculating the forecast for the future. So here, if we just see the forecast, so this is these are the forecasted values. So the forecast for the next period is nothing but what we have predicted here will be the forecast for the next period. Like for what we have predicted for the period 4th, based on 4-month moving average, it is 86. So this will be the forecast for the next period. Similarly, what we have calculated as a forecast for the 5th period, that is 94.25, it will be the forecast for the next time period. So in this way we can use 4-month moving average. So if we just see the relationship, the forecast for the next month is nothing but it will be a mean of the past data for whatever time period, 4-month moving average, 2-month moving average or 6-month moving average. So it is to note here that these n past observations are equally weighted. So if we just see all these 4 observations, they are equally weighted. Now the thing is, there are certain issues with this, like all past n observations are treated equally. Say for example, if I am interested in calculating the sales of room heaters for the month of January, then the data pertaining to December is much more important rather than what we are having for the month of October. So that is why in this moving averages, all the observations, all the n observations, 4 observation in case of 4-month moving average, 6 observation in case of 6-month moving average, they all are equally treated. All the weights of all the observations are same. Observation older than n, they are not included in this. That means if we are using 4-month moving average, so whatever happens before this, that is not being taken into account. Requires that n past observation to be retained. So if we are using this method, we must have an effective database which will retain this kind of data. Similarly, if we are dealing with large number of products and a large amount of data is to be stored, in this case, if we are using a moving one if we are using a method of moving averages. So another method is weighted moving average, just to overcome one of the limitation here, that in this case I have already told you that all n past observations are equally treated. If we just modify this and if we assign weights to different weights to each month, then this method becomes the weighted average. Of course, the summation of all weights should be equal to 1. So the thing is, the forecast for any time period, it may be calculated on the base simply by, instead of taking weight, we can simply take the weight, the forecast multiplied by the average weight. Now important thing is here how we are going to choose the weights. So weights can be chosen depending upon the importance that we feel the past data has. I have already given you example, like for example the sales pertaining to AC. So the past data in summer months, that is much more important and crucial as compared to data of winter months, depending upon the known seasonality. So on the basis of expert opinion, we can have these values which may be taken as weights to solve the problems of using weighted moving average. Now another method in this which we generally use is known as the exponential smoothing. So in this method, it is basically a forecasting technique in which past observations are geometrically discounted according to their age. The heaviest weight is assigned to the most recent data. So I already told you it is basically a better method over weighted moving average. The thing is that higher weights are assigned to the most recent data and subsequently less weights are assigned to the previous year's data. So the thing is, the main idea is the prediction of the future depend mostly on the most recent observation. So the most recent, let's say for example, the sales for the month of January of any heater or room heaters. So the thing is, in this case, the data pertaining to December is much more important rather than any other month. Okay, so the thing is, what we do, so December has already been passed. So for the month of December, we will be having two values. One is what we have predicted on the basis of on the basis of the data pertaining to November, and since December has already passed, so we have the data pertaining to actual sales. So we have two things available with us. One is the forecast, which we have already given on the basis of the previous month for the month of December, and another thing is the actual sales data. So we use these two values to predict what will be the forecast for the month of January. So the thing is, the main idea is to predict the future. The prediction of future depends mostly on the most recent observation and on the error of the latest forecast. Error simply means, say for example, if we are predicting it for future, so error means what we have forecasted and what the actual demand is. If we take the difference between the two, that will be the error. So demand minus forecast is error, and these values are available for the previous month. So somehow we try to modify this error, and on the basis of which we can predict what will be the sales in the month of January. So the thing is, in this we use a constant, what we call as a smoothing constant. It is basically denoted by alpha. So this alpha is basically the contribution of the error in the present calculation. So it denotes the importance of the past error. So the past error is being incorporated with the help of this smoothing constant, what we call as alpha. Let us see. Now for exponential smoothing, the relationship is like this. Say for example, if t is the present time, so and we wish to predict the forecast for the month of t plus 1. So the forecast for any time period t plus 1 is nothing but it is alpha times the demand of the present time period plus 1 minus alpha, the forecast that we have given for the present time period. So the forecast for any future time period at t plus 1, it will be calculated by multiplying alpha into the demand, the actual demand of the present time period, plus 1 minus alpha, the forecast for the present time period. So this will be much more clear if we take up this example. Say for example, if we are having these periods and we are interested in finding out what will be the forecast for the year, for the period 9. Okay, so we have the demand given. Okay, so if we just calculate and say for example, this forecast we are having, we call this as initialization. Initialization. We do have a period where both the demand and the forecast is known. If somehow the forecast is not known, then we can assume a suitable forecast. So say for example, if for period 1 we know the demand and we know the forecast, so what will be the forecast for period 2? So that we call as F2. So this can be calculated as alpha times dt. So alpha is 0.3. So 0.3 multiplied by the demand of the present period. So present period is 1. So we multiply it by 12. So dt 12 plus 1 minus alpha, that is 1 minus 0.3. So it gives 0.7 multiplied by the forecast of the present time period. So that is basically 10. So if we just fill these values into this equation, what we get, a forecast value for the period 2 as 10.6. So now this is the forecast value for the time period second based on the past data, that is for the period 1. However, the actual sales comes out to be 15. So now on the basis of these two data, that is for the demand for the period second and the forecast for period second, we can find out what will be the forecast for period 3. Similarly, so on and so forth. Similarly, we can find out what will, so similarly for period 3, these are the calculations. If we just for period 3, what we do, alpha times dt, so alpha is given as 0.3. Now demand for the present time period is given as 15, so we multiply it by 15 plus 1 minus alpha, that is 0.7, and the demand for the recent period, that is 10.6. If we just calculate this comes out to be 11.92, which is written here. So similarly, we can calculate all these values, and the last value we can compute. Once we know this value, then we can find out what will be the value of forecast for the period 9. So it will be 12 multiplied by 0.3 plus 1 minus alpha, that is 0.7 multiplied by 11.07. So that will be the forecast for the next time period. So this is how we utilize this formula to calculate the forecast for future using exponential smoothing. These are some more examples, like for example, if we see moving average example, if we assume n equal to 2. So this is the actual demand values. So if 2-month moving average is used, you just take the mean of these two values. So it will be 150. So the forecast for the period 3 is 150. However, the actual sales are also 150. Similarly, for the next, the most recent data is 175 and 150. You again take the mean of these two, so it will be the forecast for period 4. Similarly, for period 5, what we have, the most recent data is 150 and 150. We take the mean of these two data, again this comes out to be 150. However, the actual sales is 160. Again, for the recent two periods is 150 and 160. So if we just take the mean of these two, it comes out to be 155. So this will be the forecast for the forecast for period 6. So this is how we use moving average method. In weighted moving average, instead of this, we have certain weights, like for example, these are the actual sales given for the months, and we are interested in calculating the forecast for the month of July. So weights are given. So if we just use the weights, and 1, 2, 3, it is basically 6 months. So the thing is 1, 2, 3. So 3-month moving average. So you have weights given. So it will be 0.5 multiplied by the 3-month moving. This is basically 3-month moving average. So 0.5 multiplied by 600. Then this weight for the month of May is given as 0.3 multiplied by 500. And again, weight for April is given as 0.2, multiply 0.2 by 400. And you just sum up. So the forecast for the next time period will come out to be 530. So this is the moving average examples, and this is weighted moving average examples. So here in this case, every week is having equal weightage, but in this case the most recent period is having a higher weight, and the weight keeps on decreasing as we move on towards the past data. And again, this is weighted moving examples. If we take n equal to 2, these two weights are given. So the thing is, weight 1 is given, weight 2 is given. So higher weight for 175. So 175 multiplied by 0.7. So if we are just interested in computing the forecast for the third period, it will be this plus 0.3 multiplied by 125. It will be 160. So now we have this data. So the thing is, for the next period, the forecast can be calculated based on the two most recent periods data. So the most recent period is recent data is 150 multiplied by higher weight plus 0.3 multiplied by 175. So this will be the forecast for 4. Similarly for 5. So on the basis of 5, we can predict what will be the forecast for the period 6. So if we are interested in finding out the forecast for period 6, the two most recent data available with us is for period 5, that is 160, and for period 4, that is 150. So 160 multiplied by 0.7 plus 0.3 multiplied by 150. So that will be the forecast that comes out to be 157 for period 6. Similarly, for exponential smoothing problem, say for example, if we have these weeks and the demand for these weeks are given, and we wish to calculate the forecast for the 6th period. So initially we don't have any forecast. So I have already told you that if no forecast is available, just assume some initial value. So initially for month first week, we assume that the forecast for this month comes out to be 125, which is same as that of the demand. Now for the next time period, how we can compute the forecast? So I have already told you that if you just apply the relationship alpha dt, that is alpha is given as 0.4 into dt, demand for the most recent period, that is 125, plus 1 minus alpha. 1 minus alpha is 0.6 into forecast. Forecast is given as 125. So if you just compute this, it again comes out to be 125. So in this way, if we just apply the relationship, then we can calculate what will be the forecast for the period 6. So this is all about some of the methods which we generally use for forecasting. Thanks a lot.